A system area network SAN is a relatively local network designed for high-speed interconnection in cluster environment server-to-server, multiprocessing systems processor-to-processor, and SAN storage area networks. The job of an interconnection network in a parallel machine is to transfer information from any source node to any desired destination node, in support of the network transactions that are used to realize the programming model. It should accomplish this task with as small a latency as possible, and it should allow a large number of such transfers to take place concurrently. It should be inexpensive relative to the cost of the rest of the machine. The network is composed of links and switches. A link is a bundle of wires or fibers that carries an analog signal. A transmitter converts digital info at one end into an analog signal that is driven down the link and converted back into digital signals by the receiver at the other end. Switches steer each unit arriving on an input channel to the appropriate output channel. Many networks operate asynchronously rather than being controlled by a single global clock. The network cycle time is defined as the time to transmit the smallest physical unit of information, a FIT. For parallel architectures, it is convenient to think about the processor cycle time and the network cycle time in common terms. The minimum unit of information that can be transferred across a link and either accepted or rejected is called a flow control unit, or FLIT, as small as a FIT or as large as a packet. Switches connect a fixed number of input channels to a fixed number of output channels. This number is called the switch degree. The input port has a synchronizer to align the incoming data with the local clock domain of FIFO, providing some degree of buffering. The control logic must be able to determine the output port required by each incoming packet, and to arbitrate among input ports that need to connect to the same input port. FDDI. Digital Equipment developed the Shared Media Fiber Distributed Data Interface technology, which uses optic fiber rings to provide 100-200 Mbps transmission between workstations. FDDI can be used in full duplex mode. Using a FFDI full duplex technology FFDT, this crossbar can connect up to 22 FDDI ports in 100 Mbps. MariNet is a gigabit per second packet switch network by Maricom, Incorporated, used to build a MariNet LAN for connecting desktop workstations, PCs, an in-cabinet multi-computer cluster, and a single-board multiprocessor cluster. It is based on multi-computer and VLSI technology developed at the University of Southern California. The MariNet can assume any topology. Variable length packet format. Cut-through crossbar switches. An 8-port MariNet switch achieves bandwidth of 10.24 GB per second. Switching strategy. Circuit switching. The path from the source to the destination is established and reserved until the message is transferred, used in phone systems. Packet switching. Packets are individually routed from the source to the destination, typically allows better utilization of network resources. A network is characterized by its topology, routing algorithm, switching strategy, and flow control mechanism. The topology is the physical interconnection structure of the network graph. Direct networks have a host node connected to each switch. Indirect networks have hosts connected only to a specific subset of the switches, which form the edges of the network. Hosts generate and remove traffic. Diameter of the network - the length of the maximum shortest path between any two nodes. Routing distance between a pair of nodes. The number of links traversed along the route. Average distance. Over all pairs of nodes, the expected distance between a random pair of nodes. Separating edges. The graph is broken down into two disjoint graphs. SANs have very low error rates. SANs are often made highly available by using redundant interconnect fabrics. SAN performance more closely resembles that of a memory subsystem than a traditional network, such as a LAN. SANs provide bulk data transfer through a remote direct memory access or DMA mechanism. The initiator specifies a buffer on the local system and a buffer on the remote system. Data is then transferred directly between the two locations by the network adapters without host CPU involvement at either end. Both read, get and write put transfers can be supported. SAN applications, file server clusters, database server clusters, storage area networks SAN, web servers clusters, scientific applications. System area networks deliver very high bandwidth, more than 1 GB per second with very low latency. SANs are switched, with a typical hub supporting 4 to 8 nodes. You can build larger networks from cascading hubs. Cable length limitations can vary from a few meters to a few kilometers.